I'm Nahnsan Guseh, and I'm here to talk about ternary packages in R, specifically ggtern. So now let's begin. So what is ggtern? So ggtern is a package in R and an extension of ggplot, and this was created by a man named Nicholas Hamilton, who's from Wales. Um, it was specifically created for ternary plots and diagram. And what's nice about ggtern is the syntax for it is similar to ggplot. So if you know a little bit of ggplot, your transition over to ggtern won't be hard at all. Um, and that's what I like most about ggtern. There are other methods to creating ternary plots, and that includes using Plotly, which is another package. But after trying out Plotly, I like using ggtern a lot better. It seems more user friendly, and I already know a little bit of ggplot, so it helps with that. So let's talk about ternary plots. So ternary plots are useful for visualizing data when there are three variables and when these variables sum to a constant. And the constant is usually of 1 and of 100. And so as you see in the picture, each of these corners would be a variable. And we'll talk a little bit more about that later. But ternary plots are commonly used in the fields of chemistry, petrology, mineralogy, material sciences, and more. So now we're going to discuss how to read them. So this is very important because in some scenarios, reading a ternary plot can be a little difficult, but once you understand it, it can be fairly simple. So each of these points are a variable, and let's say this A is point A, B is point B, variable B, and green C is variable C. As you can see at variable C in this green dot, that is pure C. So that means it's 100% of this variable and 0% B and 0% A. And this line represents the green line. So this is 100% C, 80% C, 60% C, 40% C, 20% C, 0% C. And if we go to A, you can see this is pure A, 100% A. This line would be 80% A, 60% A, 40% A, 20% A, and 0% A. And it's the same for this variable over here for B. This point is pure B, 100% B, 80% B, 60% B, 40% B, 20% B, 0% B. Now, while you're reading plots, it's always important to remember to check the direction of the plot, because in this scenario, the variable A is increasing this way, variable B is increasing this way, and variable C is increasing this way. However, in R and ggtern, the default parameters actually do it the opposite way. So variable A is going this way, variable C is going this way, variable B is going this way. So we'll talk about that more. So here's my first example. So in our ISC 719 class, this would be a basic plot, a ternary plot of the types of soil in our 719 garden. This is all fake data that I've made myself. But as you can see, the gardens that we have in our 719 garden is mostly of silt and sand between these two areas, and not a lot of high concentrations of clay. Here is it a little bit more visually appealing, and maybe you can understand a little bit better. You can see sands this way, clay is this way, silt is that way. Opposite of how the last diagram showed, but and this also helps you see it as well, because you can see that sand, this is 100% sand, 80% sand, 60% sand, 40% sand, 20% sand, 0% sand. And so yeah, this just further illustrates the sand and silt concentration in our ISC 719 garden. And with ggtern, you can also make density plots. So the density plots helps to illustrate it. As you can see, the red is where it's most dense. So in this area where it's about 20 to 40% sand and 40 to 80% silt is most of our garden, with a little bit of clay, around 20%, but no more than 40% clay in any of the samples that we chose. So now, with along with using heat maps and density maps, you can also classify each of your points. And so here I classify points from the iSchool, the Archibald Building, and Newhouse. And just like we documented earlier in the iSchool, a lot of the soil samples come from sand and silt. And in Archibald, a lot of it comes from in the architecture building. I'm sorry, comes from clay and silt. And Newhouse gets their soil from all over the place. You see sand, you see high concentrations of clay, high concentrations of silt, and a lot of in between. So here's the code that I use to create all of these plots. Here are some resources if you want to know more about ggtern and more methods you can use within ggtern. And thank you for listening. If you have any questions, feel free to comment on YouTube or in the discussion board on Blackboard. And thank you.